In this video, we'll be talking about how to solve a system of three equations with three variables, and we are going to use this method of elimination. And an elimination is very similar to what we would use with a system of two equations with two variables. Here it's going to be a little bit more involved. Well, so let's call this A, B, and C, and I'm just labeling these equations so that we can follow along easier. We want to eliminate one of the variables, x, y, or z. And to do this, what I'm going to do is just take two equations. So I'll take equation A and equation B. And I'm going to rewrite them. X plus y minus z is equal to 1. And negative 2x minus y plus 3z is equal to 4. It's always good to line up your variables. Now, what I can do, notice here that I can add the equation B to equation A. And my y's will cancel out. So then I have negative x plus 0 plus 2z is equal to 5. And I'm going to rewrite this as negative x plus 2z is equal to 5. And I'll come back to this in just a moment. But notice now that we have two variables, x and z. Okay? Then I'm going to take other two equations. Now, it's important, we used a and b in our first elimination of variables. In my next one, I have to use C. And I can either use A or I can use B. So I have to use C. So I can use A or B. All right? It doesn't matter. You have to use one of them. Okay? So what I'm going to do is this time I'm going to use A and I'm going to use C. I could have used B, but I'm choosing A. So I have x plus y minus z is equal to 1. And I have 5x minus 3y minus 2z is equal to 1. Now you'll notice here that I have to multiply this top one by 3. Now, I want to try and get rid of or eliminate the same variable that I did in the previous example, in the previous equation. Otherwise, it won't be very helpful. So I multiply the top by 3, and now I'm going to rewrite my equation A as 3x plus 3y minus 3z is equal to 3. And I'm just going to write C again underneath it. Now I'm going to add these to each other. So 5x minus 3y minus 2z is equal to 1. Okay. And I'm going to add them up, and I get 8x plus 0y minus 5z is equal to 4. And I'll rewrite that without the 0y. 8x minus 5z is equal to 4. We'll call that one equation 1 and this one equation 2. Now you'll see here that I have two equations with two variables. Ah, yes, I can recall what I know about the system of two equations with two variables, and I can solve for one of the variables, right? So now I'm going to take equation 1, negative x plus 2z equal 5. And I'm going to take equation 2, which is 8x minus 5z, which is equal to 4. And I want going to, again, try and eliminate one of the variables. And how do I want to do this? Well, I will multiply, let's just multiply the top one by 8. I'm multiplying the top one by 8 so I can eliminate now my x's. See what I'm trying to eliminate my x's here? So this will be equal to negative 8x, again, we're going to rewrite number 1 here, plus 16z equal to 40. And equation 2, which I'm going to add, is 8x minus 5z equal to 4. Okay. You'll notice here that my x's cancel out, and I'm left with 11z is equal to 44. So z is going to be equal to 4. Great. And we have one of the variables here. Z is equal to 4. Now, just like how you would solve a system of 2 equations with 2 variables, I can take this and I can plug it back into equation 1 or equation 2. So what I'll do is I'll come back up here and I'm going to plug it back into equation 1. So using equation 1, I can say negative x plus 2 times 4 gives me 5. So negative x plus 8 equals 5. Subtract 8. I get negative x equals negative 3. So x equals 3. So now I have z and x. That's good. That means I can use both of these to then find what y is. So out of these equations up here, a, b, and c, I'm going to use x and z, and you can see I think a is probably the easiest one because there's coefficients of just 1. So I'll use a, and what I'll do is I'm using z is equal to 4, x is equal to 3. So x is 3 plus y minus 4 is equal to 1. And that means y minus 1 equals 1. So y has to be 2. Awesome. So our final answer here, which we write in as a point in a 3-dimensional plane, is 3, which is our x, y, which is 2 in this case, and z, which is 4. And there is the solution to our system of equations. Now, of course, we can go in, I recommend doing this, go in and plug in each of these equations and make sure that this point satisfies each of those equations. And remember, guys, if you're confused, rewatch the last video of what does this mean? What does this point mean? I'll do a quick sketch if I can try and do a quick sketch. So remember that we have one plane, which represents, right, we'll just say that's equation A. Well, let's just make that equation A. Equation A represents one plane. And then we have some other, we have some other plane which intersects that plane. Okay, and we'll call that equation B. Again, I don't know exactly. And then we have another, this is hard to draw right here, folks. You get into upper math, things don't become really easy to draw. Another like plane or so. Gosh, this is bad. Anyways, these intersect at one point. I can't do it. Here's a picture. I don't know why I just didn't do this. Looks like this. Boom. I can't draw that at all. But that's what our solution looks like graphically. It's just a point where all 3 planes meet. So we solved it by